Hello and welcome to Fixing the Future, an IEEE Spectrum podcast where we look at concrete solutions to some big problems. I'm your host, Stephen Cass, a senior editor at IEEE Spectrum. And before we start, I just want to tell you that you can get the latest coverage from some of Spectrum's most important beats, including AI, climate change, and robotics, by signing up for one of our free newsletters. Just go to spectrum.ieee.org/newsletters to subscribe. Sustainable electronics is becoming an increasingly important topic around the world, and today we're going to be talking with Liisa Hakola, a senior scientist at VTT in Finland, about the European Union's Sustronics program aimed at this very topic. I'd like to welcome you to the show. Thank you so much, Liisa.
Thank you. Nice to be here. Thank you for inviting.
You're very welcome. So, as I said, sustainable electronics is becoming a bigger and bigger topic. But it seems to be one of those things that people, talk about it more than actually doing anything about it. How is the EU Sustronics project going to help with that, and where does VTT fit into that?
Thank you for the question. Indeed, the Sustronics project is a large initiative with 46 partners from 11 different European countries. And our main topic is about finding ways to make electronics more sustainable throughout their life cycle. So not just focusing on one aspect, but taking into account different opportunities that might arise from selection of materials or manufacturing technologies or circular economy strategies that could be used. And VTT's role is, first of all, to be the technical manager of the project, to ensure that the different partners work together and the different activities are interacting with each other in order to have a joint effort. But on top of that, VTT also brings some of its technologies, mainly from printed electronics, to the project.
Is it a case that you look for industry partners who then come in and work with you? They look around, they think you're a good fit within the program, or are you actively searching out people and going, oh, we think we have some technology that might help you out here?
Well, basically it's I think the both ways. Of course, there are 46 partners already in the consortium, and over half of them are from the industry, large enterprises and SMEs. So of course they have specific needs, and we have been already agreeing during the proposal phase that VTT could offer certain technologies for them to then start testing for their products, and if that could help with decreasing the environmental footprint.
I guess the question is, why would anybody join the program, especially if you're a manufacturer and so on? I mean, as a citizen of Earth, I think it's a great idea, but we often hear about bottom line issues and so on. What's the incentive if you are somebody who's making electronics to become one of these partners?
Well, first of all, in the EU, we have this Green Deal. So the regulations and the legislation is developing into a direction where all of the companies in the EU have to take into account the sustainability aspects of the products they are developing and selling. So in order to achieve that to be able to meet the requirements coming from the EU side, the companies need to develop new ways to maintain or improve sustainability of their products. And this is one opportunity, because collaborating with the research institutes and universities, the companies get access to kind of technologies that have been in development in those, and then they can try them out in their own products, and then in that way to get closer to meeting the sustainability requirements.
So we're based in New York, in the United States, where it's quite a different regulatory regime. But can you tell me, what is the enforcement mechanism for those sustainability regulations? Like, what happens if you don't do it? Is it, because I can imagine some people are just thinking, oh, it's just a slap on the wrist, or it's a fine, it's just a cost of doing business. How those rules really enforced?
Well, of course, EU is developing the regulations all the time, so there might come new enforcements in the future. But the upcoming regulation about eco-design for sustainable products, so that regulation demands that there is going to be a digital product passport that would give information about the environmental impact of the product. And that kind of information would be available even for consumers. So actually, if the consumers are environmentally aware, they would start selecting the products that are environmentally friendly. So that's, of course, quite strong way to make companies work towards making more sustainable products, because if consumers start selecting the sustainable products, then the non-sustainable ones will lose their market share.
So you talked a little bit earlier about the entire sort of life cycle and sustainability. Currently, what are along that life cycle, what are some of the biggest obstacles that currently exist towards making electronics more sustainable?
Well, there are a couple of things that are quite dominant. So first of all, the raw materials that are used for making electronic products, they are mostly fossil-based, like different metals that are needed for making conductive structures. And also the substrates where the metals are put, they are usually based on some plastics or plastic composite materials. And then we are actually talking about materials that are critical or rare or quite valuable. So it's quite a challenge to find materials that could substitute the existing materials, because we know that those are well-performing. So can we actually find some sustainable alternatives for them? And another thing is, of course, that the processes that are used for making circuit boards, for example, they consume quite a lot of energy and raw materials, and that, of course, is not very good for the environment, because it's not very energy or material efficient to manufacture in a way that a lot of material is wasted and processed several times. And of course, the whole electronics industry is quite complex and fragmented industry. There are a lot of layers, and it's really difficult to get them all to work together and sort of transparently transfer data and information between the different players.
So I'd like to go into that, and maybe this is some of VTT's specialist expertise, and talk a little about the work that you've been done in materials specifically then.
Yes, so VTT has focused quite a lot on replacing the fossil-based substrate materials with materials that are bio-based or renewable materials. And well, in Finland, the forest industry has typically been quite strong. So of course we have studied how to use the cellulose-based materials like paper as a substrate for electronics. But there are also a lot of these biopolymer based substrates that are basically, they look and feel like plastics, but they are from bio-based resources. So they are kind of renewable, and some of them are really easy to recycle, or some of them can even be compostable.
And you said compostable there. I'm a little worried because I have these, compostable plastic bags in my kitchen that just don't last very long. And so when you said that, I'm a little concerned about putting that in my electronics, or is it for very short-lived sort of disposable electronics, given some of them have very short life cycles?
Yes, if we are talking about using printing as a manufacturing technology, so then of course we are able to manufacture electronics that have a shorter lifetime, and they can be even used just one time. But if you produce a lot of electronics that is for single-use purpose, then actually you are creating a lot of new electronic waste. So you have to somehow tackle this issue with having single-use electronics, but then being able to somehow recycle or dispose that electronics. And in that case, if there is, for example, some diagnostic device where you measure something, then probably there would be like a single-use part on that device that could then probably be compostable. But then there would also be a reusable part. So after doing some diagnostic measurements, you change only one piece of the device, and then that changeable part would then be compostable, or it can also be that the recycling process is established and it would be easily recyclable. But in that kind of cases, you might think about the compostable solutions also.
So I'd like to talk a little bit more about recycling there. Electronic waste is notoriously very difficult to waste. We have to separate out our electronic waste, and we have to put it somewhere else. There are special pickup days, and sometimes, which I do dutifully, but then I sometimes think about when all this stuff is put on the van, like, how is anybody going to realistically recycle that 10-year-old broken projector or those collection of printers and so on? How do you make recycling work better?
Well, yeah, that's of course a matter of first of all, you need to establish the recycling process, and there would have to be different collection bins where people could dispose their electronics. But of course, I come from Finland. Actually, in my apartment where I live, there are something like 7 different recycling bins where I put the different type of waste. So adding their 8th bin for electronics wouldn't be that big of an issue. But if you think recycling also from the scratch, then the electronic devices actually have to be designed in a way that they are better for recycling. So we talk about circular design, for example. Already in the design phase of the products, you actually think about the recycling and then design the electronics in a way that it's, for example, modular, so you can disintegrate the different components easily and recover the materials. So actually everything starts in the design phase.
Does this also help with things like serviceability or repairability? I find myself that sometimes it's easier for me to repair something that is 40 years old. I've brought these products back from the dead, but a product I buy, today is just it's a blob. I have to use very specialized tools to get it open if I can. I also have to send away for a special kit. Is part of this design process also looking at those issues?
Yes, that's the same thing, that already in the design phase, design the devices in a way that parts can be replaced later on, and people don't have to buy the new model. I understand that, of course, for the electronics companies, their business to sell new models all the time, but perhaps they can find a suitable business model also from repairing the devices. There could be some business opportunities also.
So you talked a little bit about manufacturing processes and making those a little bit more sustainable. Can you expand on that?
Yes. So what VTT has been developing for over 20 years is printed electronics. So it means that we are using printing as a manufacturing technology for electronics. And compared to the current state-of-the-art electronics manufacturing, printing is an additive method. So we actually add materials only where they are needed, and we don't strip them away later on and then try to figure out what to do with that kind of material. So that's like an opportunity for electronics manufacturing to decrease its material, but also energy consumption. We have carried out some life cycle assessment analysis where it has been shown that the printed electronics consumes less energy during manufacturing than traditional manufacturing. So there is actually already an opportunity there. But besides this energy issue, the bio-based and renewable substrate materials are already compatible with the printing technology. It's actually quite challenging to print those, for example, paper as a substrate to traditional electronics manufacturing. But for printing, it's quite easy because you know that you can print on paper. So using that to make electronics is a kind of easier task.
So can you talk a little bit about some of the sort of very concrete examples you've developed with some of your partners?
Yes. So if you think about the Sustronics program, so there are actually a lot of development for these single-use diagnostic devices. So the goal is to develop the kind of devices that people can actually even use at home to measure something from their saliva, or they can monitor how the wound is healing by having just like a plaster type wearable device on their skin. And other things that we are developing are also these other wearable devices that are not for single use, but they are like for sports and fitness sector, where you can monitor how you are doing when you are exercising, and you can even measure your heart rate, and then the app you would have in your mobile phone would then tell you based on the measurement data that okay, you did well today or something else. And one application area that VTT has been developing quite a lot devices already in the earlier research programs are these solutions for intelligent packaging. So if we talk about the packaging industry, and there is a lot of needs in the logistics of packages to measure, for example, temperature, to make sure that the cold chain has not been broken and your products are not spoiling. So VTT has been developing electronics for that, like sensors attached to packages, electronic sensors that can transmit the information to mobile phone. But if you think about the packaging industry, the packages are recyclable. So then actually if we are adding electronics there, then the sustainability of these kind of smart tags, how we could call them, would be a really important aspect to consider. And there, these new kind of materials like using paper as a substrate for electronics have a really important role.
And how long do you think it'll be before we start seeing these products like in the marketplace as something that consumers can sort of see and feel for themselves?
Well, actually, some of them are already on the marketplace, of course, not like in really huge volumes, but there are, for example, contract manufacturers for printed electronics that manufacture something that is used as a part of a device that is sold in the market. But of course, we can't print a mobile phone with this kind of technologies, at least not yet. So it depends. Perhaps some of them are already there. For some of them, it might take 3 to 5 years, and some even longer. But let's say during the next decade, there would certainly be product announcements.
And so you mentioned manufacturers. Where are these manufacturers located? Are they sort of, local manufacturers, or is this something that we can see that is being integrated into the global supply chain in terms of, those great manufacturing centers in China, for example?
Yeah, well, of course, the printed electronics contract manufacturers, they are not really large companies yet. They are still at the early phase, but and they are located all around the world. Probably quite many of them in Europe, because in Europe we have been investigating printed electronics quite a lot. But yeah, there is no issue why they couldn't be part of the global supply chains. But as we think what is the strategy of the EU, we actually want to, the EU wants to also move again back to the European supply chains also to sort of maintain the local strategic availability of key technologies. So I think in the EU there would be probably quite strong support in the future for making more manufacturers coming back to Europe, or at least establishing new manufacturing units to Europe.
So if you could wave a magic wand and solve one problem right now that's on your desk, what would that be?
Well, probably I would make the products more repairable or reusable. I've personally had some issues with the devices recently, and it has been a bit of annoying that there is no repair option. So I've been forced to buy new devices, although I have not wanted to do so. So probably I would change the business a bit, that the repair would always be an option, unless you have something that is like 50 years old. Perhaps that would be an issue. But even for like a 5-year-old device, it would be nice to have a repair option. So I guess I would develop the kind of design for the electronics that they really can be repaired or reused.
Can you talk a little bit more about Finland's history with you? You said it has this history coming out of the cellulose industry. So can you talk a little bit more about that point, about how Finland's experience with cellulose and paper sort of fed into this program?
Yeah, perhaps the background is so that Finland has a long history of paper and forest technologies, and the first printed electronics projects that were initiated in Finland more than 20 years ago, there the role of the paper companies in Finland was really strong. So actually, at least in Finland, how we started to investigate printed electronics, the initiative was involving quite a lot of these forest industry companies. And that's how we also at VTT got involved with using cellulose-based and paper as a substrate for electronics. And if you think about the sustainable electronics, the paper has been there first, and only later came the other alternatives like biopolymers. So I guess in the early stage, the paper industry was actually looking for new business opportunities, and they thought that it can be found from printed electronics, because printing on paper is like something that is being done all the time. So that's how I think the thing started, at least in Finland.
So this is a fascinating topic which we could talk about all day, but I'm afraid we have to leave it there. Today we were talking with Liisa Hakola from VTT about sustainable electronics. It was so lovely to have you on the show.
Thank you. It was lovely being here.
And for IEEE Spectrum, I'm Stephen Cass, and I hope you join us next time on Fixing the Future.